Hello everyone, welcome back to my channel. Today let's go over a hard premium question that I just solved on my own. So I'm really happy about this and wasn't expecting to solve it on my own, but I did, so let's go over it. Basically, you're given a garden of n flowers, and each flower has an integer beauty value, which is just each integer in this array, and they're arranged in a line. You're given this array of size n. Basically, you want to find a subarray and its sum where the first and the last element are equal. So this is a sum as well. This is valid as well, because 1 and 1, the first and the last are the same. And then you just want to find the maximum beauty of this subarray. So for example, here you get rid of the -3 because that's not going to make the overall sum bigger. So find the biggest subarray sum where the first and the last elements are equal. And yeah, so you can also remove elements in between, because a garden has to have at least 2 flowers and the first and the last have to have the same value, and you can remove. So if we want to maximize the sum, we just remove the negative values. So let's go ahead and actually keep track of all the indices of where each value appears. So for I, F in enumerate flowers, we're going to just say, we're going to create a dictionary, and we're going to append I. So what that gives you is just, so 0 and 3, 0 and 3, starting and the ending, 1 and 4. And again, there's going to be more than one index or 2 indexes at some time. So for example, here you have 1, 2, and 4. In that case, just try to find the largest subarray. Basically take this range, remove any negative numbers from it. So that's what you want to do. And to avoid time limit exceeded, we're going to use prefix sum. And you'll see this comes in handy later. But now we can just iterate over our dictionary. So for each one, we're going to basically say the low index is dk of 0, and the high index is dk of -1, right? So 0, 1, 2, 3. And then we have to remove the negative numbers. So the way we're going to do that is actually keep track of all the negative indices. So if f is less than 0, then negative.append I. And to get this subarray sum, we're going to use prefix sums. So the current sum is going to be, well, if low is less than or equal to 0, then the current sum is just going to be p of high. Otherwise, it's going to be, for example, if you want to find this subarray sum, it's prefix of this minus prefix of this, right? Equals to p of high minus p of low minus 1. Okay, and then after that, what you can do is just remove any of the negative numbers. So for n in negative, right, because these are the indices of all the negative numbers. So for example, there's going to 0, 1, 2, 3. So and we don't want to remove the first and the last element because they have to be the same, right? So we're going to go from the first index of the subarray to the second to last element. If we're looking at this subarray, then we only care about negatives in this range. So if low plus 1 is less than or equal to whatever this index is, that was a negative number, which is less than the high, then we're going to just subtract flowers of n, because that's the index that's a negative, that's within the range we're looking for, from the result. And then we're going to calculate the subarray sum. And then we can just return result at the end, right? So each subarray sum, removing all the negatives, having at least 2 elements. So again, the size of the dictionary has to be at least 2 for this to be valid, right? Because it says right here the garden has to have at least 2 flowers. And here, result shouldn't be 0, it should be -infinity, because the best answer could be negatives, right? So, and there you go, passes all test cases. So again, pretty proud of this, solved the hard without looking at the solution by myself. So that's it for this video. Thank you for watching, and stay tuned for more.